All right, let's dive right in. Today we're talking about a pretty huge breakthrough in chip technology. I'm talking about a tiny piece of silicon that could totally change the game for artificial intelligence. But to really get why this is such a big deal, we have to start with a really important question.
We all see it, right? AI is getting exponentially more powerful. But behind the curtain, the hardware is seriously struggling to keep up. These massive AI models that are changing our world are incredibly hungry for power and data, and they're pushing our current tech to the absolute breaking point.
For a long time, we lived by Moore's law. If you wanted more power, you just made the transistor smaller. Easy. Well, that party is pretty much over. We're now in a post-Moore's law world, where the energy bills for data centers are just astronomical, and scaling up is getting incredibly difficult. This has created a massive bottleneck, so the industry has to get a lot smarter about how it innovates.
Now, to understand the solution, we've got to look right at the heart of the problem. And it all comes down to a component that's often overlooked, but it's one of the most critical pieces of silicon inside any advanced chip today.
Yeah, you heard that right. On a modern AI chip, what we call an XPU, more than half of that precious expensive real estate is taken up by on-chip memory. That just shows you how vital this stuff is. So you can imagine, any improvement here isn't just a tiny tweak, it's a massive game changer.
So, what exactly is this memory? It's called SRAM, which stands for Static Random Access Memory. Think of it as the processor's own personal, super-fast workbench. When that chip needs to do some heavy thinking and make calculations at lightning speed, SRAM is where it keeps all the data it needs right now.
Okay, to really put this in perspective, let's compare it to the memory you probably know, DRAM. Imagine a master chef in a busy kitchen. The SRAM is that small, perfectly organized prep station right next to the stove. Every ingredient, every tool is right there, within arm's reach. The DRAM, that's the giant walk-in fridge down the hall. Sure, it holds way more stuff, but it takes time to run down there and get it. And for AI, that delay is a total performance killer.
And this is why SRAM innovation is so absolutely critical. According to Marvell's chief memory architect, Darren Anand, once you get down to these incredibly advanced tiny 2nm chips, SRAM is the only game in town for on-chip memory. You literally cannot put DRAM on that same piece of silicon. It's just not physically possible.
So if SRAM is essential, but it's also a space and power hog, what do? Well, this is where Marvell comes in with a breakthrough that tackles this problem from 3 different, very powerful angles.
What Marvell did was completely re-architect SRAM for this new 2nm world. This isn't just a little update. They basically tore up the old blueprints and started fresh. And what they created fundamentally changes the rules of chip design by delivering massive gains in 3 key areas.
First up, power. This new SRAM slashes standby power consumption by up to 66%. Think about it. A massive data center where thousands of chips are just sitting there, waiting for a task, they're still sipping power. This reduction translates into huge savings on energy and cost.
Next, let's talk about space. Because the new design is so much more efficient, chip designers can actually get back up to 15% of the total die area. That is incredibly valuable real estate that they can now use for more compute cores, making the whole chip smarter without making it any bigger.
And then, there's the big one, the showstopper, performance. This custom design delivers a 17 times increase in bandwidth for the same amount of area. That's not a step up, that's a quantum leap. It lets data move around that chef's prep station at a speed that's just mind-boggling.
Just look at this chart. It really says it all, doesn't it? On the left, you've got the industry standard, and on the right, you've got Marvell's solution. The difference is just staggering. It's like they tore out a 2-lane country road and replaced it with a 17-lane data superhighway.
But here's the really cool part. This incredible SRAM innovation isn't just a one-off thing. Nope. It's actually a key piece of a much larger, much more strategic puzzle.
See, Marvell is attacking this memory bottleneck from every possible angle. It's a whole custom platform. They've optimized the SRAM, sure, but also the connections to the external high-bandwidth memory, the super advanced interconnects that link different chiplets together, technologies like CXL for expanding memory across a whole system, and the high-speed SerDes that basically act as the chip's central nervous system. It's about making every single pathway for data faster and way more efficient.
And just look at what this custom approach does for HBM.
the next layer of memory. By redesigning how the chip connects to it, they free up enough space for 70% more compute power on the chip, while at the same time slashing the power needed to access that memory by 75%. So you get way more muscle for way less energy. That's the dream, right?
Now, the secret sauce that holds all of this together is Marvell's die-to-die interconnect tech. It's this ultra-fast, super efficient fabric that lets all these custom parts talk to each other flawlessly, and it's running a full generation ahead of what anyone else in the industry is even doing.
So, what does all this crazy advanced engineering actually mean? Let's bring it back down to earth and talk about the real-world impact this is going to have on the future of AI.
You can really boil Marvell's whole strategy down to 3 levels, starting from the inside and working our way out. First, right on the die, that new SRAM delivers absolutely massive bandwidth. Second, inside the chip's package, their custom HBM adds a ton of compute power and capacity. And third, at the whole system level, they make it easy to expand memory for even the biggest, most demanding AI models.
And the bottom line? The result of all this is that AI's incredible growth doesn't have to hit that wall. It means we can build larger, smarter, more capable AI models. It means we can get the crazy energy costs of AI under control. And that's the kind of foundational tech that enables breakthroughs in everything from medicine to climate science.
Which brings us to a really fascinating final thought. We thought we were hitting a physical wall in computing, but with innovations like this, that wall is actively being pushed back. So as these new, way more powerful chips become the foundation for the next generation of AI, you have to wonder, what kind of sci-fi level stuff that seems impossible today will suddenly become possible tomorrow?